Hello everyone and welcome back to TAL, also known as Teach as We Learn. Today I'm going to be teaching you how to solve literal equations. So let's begin. So if you notice on the board, I have written only letters. And yes, I've been writing like X, the letter X in my other videos, right? Because those are X variables. But I have never written an equation with all letters. So why have I written all letters today, you may ask? Well, the reason that I've written all letters, no, I've not gone crazy, because this is math. This is algebra. Welcome to literal equations. Basically, these letters are also variables. So if you remember, right, from past videos, our X variables was that mystery number, which we were always trying to solve. However, in this literal equation, it's a little different. God, erase the C. But A could equal the amount of blue candies. Then B could equal the amount of red candies, and C could equal the total amount of candies. So this is just how it works with literal equations. But if we want to solve for the amount of blue candies only, then we would solve for A. Right? We would solve for the amount of blue candies only. These are blue candies, red candies, total amount of candies we have. And we want to figure out, and will just write that over here so we don't forget. So A is our blue candies, B is our red candies, and C is total amount of candies. And we want to figure out the amount of blue candies. So what equation can we use for that? Right, so we just want to know amount of blue candies. So basically, we would want A to be all alone, right? Because we would want our equation to look like A equals blah, 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 right? We want to figure out an equation that we can use to figure out the amount of blue candy, right? So this is just an equation. We won't be using like numbers. We're just using variables. So basically, on total amount of blue candies. So the only thing, if we want A to be all alone, so whenever it says solve for like a specific letter, solve for A, that literally just means they want this. So in this case, we're solving for A, so we just want solve A equals. So if we want it to be A equals, then we just want the side to be A, right? We don't want B. So how we usually do with solving equations or inequalities, we will also just move B right over here, right? And what can we do to erase the B? So it's adding B, we just minus B. And whatever you do on one side, got to do it to the other. So yeah. So basically, A is C minus B. That's the equation that you would use to for the number of blue candies, or to solve for A, right? Because we did A equals blue candies. A way to double check if your literal equation is right is that you can just give random values to your literal equation. So we could say A was 20 blue candies. We had 20 blue candies, then we had 30 red candies, right? And then C would automatically be 50 if we look at this, right? So we would have plugged in 20 in our example, like the original equation, 20 plus 30 equals 50. And then if A is 20, then we would pull up that 20 equals C, which was 50, minus B, which is 30. And does 20 equal 20? Yes. So our equation, literal equation, is correct. Basically, this is how it works. Now I'm going to be doing another example. So this is mx plus y equals b, and this is pretty much the same thing, right? We could just maybe do it a little different. Maybe mx could be small books, or mx could be large books, and y could be small books, and then b could be the total of books. But what if we want to solve for how much small books they read, because the teacher's like, maybe you can't read the small books. So the teacher wants to solve for y to see how many small books did the child read, or her student read. So we have, right, so mx plus y equals b, we're solving for y. So then we can, b is already on the right side, and all we have to move is mx to this side. And if we want this side to be y only, or y, right, y only, or like y plus 0, basically we would subtract mx, because that would make it 0 or y, right? So doing the reverse operations, so this is right now a positive mx, like we're adding mx, so then we would subtract mx to get rid of it. So we subtract mx here, and then whatever you do on one side, you got to do it to the other. And then we do minus mx, and then we get y equals b minus mx. Bingo. So that's how, this is an example, 2 examples of literal equations. But then you might experience a different one, meaning that instead you may get f equals ma. And many of you might recognize this little equation because this is actually a real life example. Force equals mass times acceleration. And if you notice a difference between this one equation and this equation, that here it said, we could see the plus sign, right? But here we don't see it. We don't see any plus sign. We just see an equal sign. The reason being is because mass, or m, and acceleration, or a, are not being added. They're being multiplied. So you can almost imagine a imaginary multiplication sign over here. So suppose if we want to figure out a mass of an object, so we would solve for m. So force is already on the side we want it to be, so we just have to get rid of a, or acceleration. So remember, you do the reverse operation. So if it's times a, then we would divide a, because it's the reverse operation of multiplication's reverse operation is division. So we divide a, and a is successfully gone from this side. And then whatever you do on one side, the other. So basically our new formula is mass, or m, equals f divided by a. So we know this is the correct answer because this formula is actually used in the real world. However, if you wanted to double check, then you could have just assigned it random values, which would have worked as well. So this is it for literal equations.